All right, so now we're going to talk about a couple new postulates. Now this has a lot of definitions, so if you need to pause the video and copy some stuff down, please do so. So starting with the parallel postulate. If there is a line and a point not on the line, then there is exactly one line through the point parallel to the given line. Okay, what does this mean? This means if we have a line, we'll call this one line L. See how it says L right here? So we have line L, and a point not on that line, point P. Then if I asked you to draw a line through point P that's parallel with point L, with line L, there's only one way to do it, and it would be looking like this. There's no other way that you can draw a line through point P that's still parallel to line L that doesn't look like this. There's only one option. So there's exactly one line through point P parallel to L. If I asked each person in class to do this, you guys would all come up with the exact same looking line. Very similar is the perpendicular postulate. If there is a line and a point not on the line, then there is exactly one line through the point that's perpendicular to the given line. What does this mean? Okay, if there is a line, line L, and a point not on the line, point P, then there is exactly one line through the point perpendicular to the given line. So that means if I ask you to draw a line perpendicular to L that goes through point P, you only have one option. There's only one way to draw that. So there's exactly one line through P perpendicular to L. All right, let's work on an example. Here's a diagram that I drew. I want to name a pair of parallel lines. Name a pair of parallel lines. So some notation. You see these little arrows right here? Those little arrows? That's trying to tell you that this is parallel to something. It's parallel to something that has the same number of arrows. So this guy and this guy have the same number of little arrow signs. That means that they're parallel. So if I had two lines like this, each with one set of arrows, they'd be parallel. And if I had another set of lines intersecting it, and they had two little arrows, that means those two lines are parallel to each other. So these two lines are parallel to each other, and these two lines are parallel to each other. It's all about matching up the number of little, kind of like our tick marks. Okay, so let's name a pair of parallel lines. Looking at this picture, I see two lines with the matching number of little arrows, and those lines are, I'll call it DM and EF. Now remember, you could have called that MD and FE, doesn't matter. Name a pair of perpendicular lines. That means we're looking for two lines that meet at a 90-degree angle. Usually that's signified by a little corner square. I see a little corner square right here. So which two lines are perpendicular? I see this one. So that's line, we'll call that DM, is perpendicular to this line, line BF. Now this diagram might look a little misleading. You might be like, oh, that doesn't look like a perfect straight angle. But if you have a picture that shows you a right angle, a corner, then you have to trust the picture. The picture is telling you what it is. You can't assume anything unless it gives you notation, and here we had notation. Okay, is EF parallel to AC? Is EF parallel to AC? Well, first we can use our eyes and say, well, they kind of look like eventually if I extended these guys, they would touch. But what we really want to get used to doing is looking for notation. I don't see any arrows that match here on line AC. I don't see any of those. So I'm going to say no, they're not parallel. There's no notation or no little arrows. They'll meet eventually. They'll eventually meet.